So the GripTight binding project is showcasing how we design, build and test products here at Deakin, which exemplifies the process that we take our students and academics through to ensure that we build better products. Design is critically important. The marketplace is extremely competitive. Consumers now, more so than ever, expecting to see good design in all their products. The action sports industry is not immune to this. We must continue to design and develop better products for the market.
We're involved in sports technology because we have the opportunity to combine that fundamental science and with technology and take that effect to product development and product design. So we get the opportunity of using the full spectrum of product development from science, technology, and target that to a specific audience and target that to the global market.
The motivation from my project came from my wanting to tie my love of snowboarding into my engineering studies. Because snowboard binding technology hasn't changed much in the last 20 or 30 years, we're really able to use this new 3D printing technology to create new designs that weren't possible in the past.
It's great to see our students motivated by their passions, how their curiosity and problem-solving skills really increase, and that is all reflected on their outcomes.
Functional prototypes are critical to any design process. The act of taking an idea, building the concept and taking it out into the real world is critical to ensure success.
The binding had to meet the needs of the snowboarders. We sent a survey out to almost 300 enthusiast and professional snowboarders all around the world, and they identified that they needed a binding that was pain-free as well as responsive. The three concepts that we ended up with were adding and removing straps, running straps down the side of the binding, as well as a steel cable system called boa that ran over the top of the boot. By consulting with our focus group of professional and enthusiast snowboarders, we were able to combine all three of these concepts into our final product.
We are confident with all the simulations and the results that we have to date that these bindings will not only work but survive quite a few runs on the hill. The theory of going to the mountain is the culmination of 12 months of hard work. We want to test these unknowns, ensure that all our assumptions, all our theories, all our ideas actually do work.
The uncertainty of strapping into a binding at the top of the mountain that we'd designed and printed using a 3D printer was something I'd never experienced before. After the first run down the mountain, knowing that our binding had worked, it really validated the time and effort we put into the project over the last 12 months. The binding eventually did fail after 4 or 5 runs down the mountain, and it failed in a way that we'd expected and predicted throughout the computer simulations that we'd undertaken earlier in the project.
The future of sports technology is hard to predict because it's depending upon a lot of different variants. But if I was to choose one, I would say biofeedback is a big one to come, and personalized products. That real-time data that tells you what you're doing wrong, how can you correct a specific posture or an outcome.
Deakin University is well placed to do these projects. We're only 20 minutes away from the home of modern surfing. We're only 4 hours away from our closest ski and snowboarding areas. We have the technology, we have the ideas, we have the people to progress sports and sports technology. We are a progressive place that can actually take your idea and turn it into a tangible concept.